Good morning, students. All. Today we'll try to finish this ray optics by doing some more problems. Okay. See, the refracting angle of a prism A and the refractive index of the material of the prism is cot A by 2. The angle of minimum deviation is how much they are asking. Let's see here. So mu is equal to, what is the formula? Sine of A plus dm by 2 by sine A by 2. This is the formula for refractive index. Refracting angle A only they gave. Refractive index they gave cot A by 2. So cot A by 2, mu value is cot A by 2. This is equal to sine of A plus dn by 2 divided by sine A by 2. Now cot A by 2 means we can write it as cos A by 2 by sine A by 2. Cos A by 2 divided by sine A by 2. This is equal to sine of A plus dm by 2 by sine A by 2. Sine A by 2, both sides will cancel. This cos A by 2, you write it as sine of 90 minus A by 2 is equal to sine of A plus dm by 2. Both sides signs we can remove. So here 180 minus A by 2. This one by taking LCM. Here this is equal to A plus dm by 2. Here they are asking deviation is how much? Minimum deviation, dm value. dm is equal to 180 minus 2A. Okay. So this is the answer, 180 minus 2A. Okay. Next, see the second question. A prism having refractive index √2 and a refracting angle 30 degrees has one of the refracting surfaces polished. A beam of light is incident on the other refracting surface will retraces its path if the angle of incidence is. You see what is the question here is, here there is a prism. Like this. This angle will be 30 degrees. Okay. So one light ray is incident in this manner. This is the normal. Okay. It is refracted like this and reflected back like this. Then this angle is how much they are asking. Okay, this is 16, 30, na? This will be how much automatically 90. This will be how much 60. Because three angles sum in a triangle will be equal to 180 degrees. So this angle will be how much? 30 degrees. Yes, you can find now. So mu is equal to sine I by sine R. Mu value √2. This is sine I. This is sine 30 degrees. So sine I value will be √2 into sine 30. √2 into 1 by 2. This value 1 by √2. This is sine 45 degrees. I is equal to 45 degrees. Okay. See the next problem. X is a small angled prism of angle 3 degrees made from a material of refractive index 1.5. A ray of light is made incident as shown in the figure. M is a plane mirror. The angle of deviation for the ray reflected from the mirror M with respect to the incident ray. Now here what is the deviation means? D is equal to mu minus 1 into A. Mu value will be 1.5 minus 1 into 3. So 0.5 into 3 means 1.5 degrees deviation will be there. Okay. So if we extend this light ray, and if you extend this light ray backward, this angle is how much they are asking. So this value will be, you draw a normal here, this value will be 1.5. This value is also 1.5. This value how much then? So what we have to find? Angle of deviation for the reflected ray with respect to the incident ray. Angle of deviation of a reflected ray with respect to incident ray. 180 minus 1.5 degrees. So this value 178.5 degrees. Okay. See the next question. Achromatic prism is made by combining two prisms P1, P2. For that mu V, mu R values are given. Mu is the refractive index. Angle of the prism P1 is 10 degrees. What is the angle of the prism P2 is how much? So, okay. First, average refractive index of prism P1 we will calculate. For P1, mu1 is equal to 1.523, 1.515 by 2. So this value will be 1.519. Next, for P2, mu2 I am assuming 1.666, 1.650 by 2. So this will be 58 will come 1.658. That is mu1, mu2 values. So here only the net deviation is 0, they mentioned achromatic prism. So mu minus condition is mu1 minus 1 into A1, mu2 minus 1 into A2. So this is 1.519 minus 1 into A value will be 10 degrees. 1.658 minus 1 into A2 value we had to find. So here A2 is equal to 0.519 into 10 by by 0.658. So if we calculate, this is 7.8 degrees. So this is the answer for it. Next, a ray of light is incident on an equilateral prism placed on a horizontal table. For minimum deviation, which of the following is true? For minimum deviation, QR should be parallel to the base. Okay. So for minimum deviation, QR is parallel to base of prism. Okay. So this is the answer for it. QR is horizontal. Next, a beam of light consisting of red, green, and blue colors is incident on a right-angled prism as shown in the figure. The refractive indices of the material of the prism for red, green, and blue colors are 1.33, 1.44, 1.47. This prism, what it will do, that is the question. Okay, you find the refractive index of the prism. Here normal incidence, so mu is equal to 1 by sin c. Okay, mu value, so this is 1 by 45 degrees. So 1 by root 2. This will be root 2. This is 1.414. Okay. If refractive index is for that color is greater than 1.414, it will came out. Remaining, it will stops. So here 1.33, 1 will separate from the remaining. Okay. Therefore, this prism will separate the red color. Prism will separate the red color from green and blue colors. Okay, see the next question. Prism of refractive index 1.5 is immersed in water. A beam of light is incident normally on the face AB, is totally reflected to reach the face BC if, okay, see here what will happen means light ray is incident in this manner normally. Okay, and again here it is total internal reflection taking place. This angle theta, how much? Here light is going from glass to water. So mu g into sine theta is equal to mu w into sine 90. Okay, mu g value will be glass 3 by 2. They gave 1.5. Water they gave refractive index 4 by 3. So sine theta is equal to 8 by 9. Okay. Theta is equal to sine inverse 8 by 9. So sine theta greater than 8 by 9. There will be total internal reflection. Therefore, if sine theta greater than 8 by 9, total internal reflection will takes place. Now see the next question. Ray of light is incident at an angle I on the surface of a prism of small angle A emerges normally from the opposite face. Refractive index of the material of the prism is mu. Angle of the incidence is nearly equal to. Okay. So light ray is incident at an angle of I, small angled prism, and emerges normally from the opposite surface. So here it is entering from the A, 1 into sine I is equal to mu into sine R value here it will be A. For small angled prism, I is equal to mu into A. This is the answer. Next. Prism having an apex angle 4 degrees and a refraction index 1.5 is located in front of a vertical plane mirror as shown in the figure. Through what total angle is the ray deviated after reflection from the mirror? So what is the deviation by the prism? You calculate. D is equal to mu minus 1 into A. 1.5 minus 1 into 4. This is 2 degrees. So this is 2 degrees. This is by prism deviation. Next, by mirror. Take it as D1 then. D2 is equal to 180 minus 2i. I is here D. 180 minus 2 into 2. This will be 176 degrees. Therefore, total deviation is equal to D1 plus D2. 2 plus 176. This value will be 178 degrees. Next, a thin prism of angle 15 degrees made from a glass of refractive index 1.5 is combined with another glass of refractive index 1.75. This combination of the prisms produces dispersion without deviation. Angle of the second prism is. So condition for dispersion without deviation is mu1 minus 1 into A1 is equal to mu2 minus 1 into A2. 1.5 minus 1 into 15 is equal to 1.75 minus 1 into A2. Okay. So this value A2 is equal to 0.5 into 15 by 0.75. If we calculate this one, finally we'll get it as this is 7.5 divided by 0.75, 10 degrees. Okay, so this is the answer for it. Next, glass prism is dipped in water. Its dispersive power. Dispersive power formula omega is equal to theta by d. Okay, theta same, d value in air. D is equal to mu minus 1 into A. In water, D is equal to mu G by mu W minus 1 into E. Here what happened is deviation will decrease. Deviation decreases means omega will increases. Here d in water, d value will decrease. Therefore, omega value will increase. So increases is the answer. They typed wrong option. Decreases, increases will be the answer for this problem. When you are studying the material, you check it. Increases will be the answer. Modify it. A microscope has an objective of 5 mm. Focal length of the eyepiece will be 30 mm. 30 mm focal length, and the distance between them is 150 mm. Its magnification will be how much? So m is equal to LD by FOF. Here 150 mm means 15 centimeter. D value 25 centimeter constant. Focal length of the objective, you do one thing or otherwise. Convert all into millimeter. L value 150 mm. 25 centimeter means 250 mm. This is 5 mm, this is 30 mm. 150 will cancel. Therefore, m is equal to 250. Next, 50. Compound microscope has magnification of 30 degrees. Focal length of the eyepiece is 5 centimeter. Final image is formed at the least distance of distinct vision. Magnification produced by the objective will be how much? So here, compound microscope net magnification is how much? 30. Focal length of the eyepiece will be 5 centimeter. Final image is formed by, so m focal magnification of the objective will be how much? So m is equal to VO by UO into 1 plus D by FE. This VO by UO will be magnification of the objective into 1 plus D by FE. Then all are given. So m value will be 30. M naught value we have to calculate. D 25, FE value 5. So m naught is equal, MO is equal to 30/6. This will be 5 centimeter. Next, 58. Galilean telescope measures 9 centimeter from the objective of the eyepiece. The focal length of the objective is 15 centimeter. What is its magnifying power? So, see, Galilean telescope measures 9 centimeter from the objective to the eyepiece. So, L value, they gave it as 9 centimeter. Okay. Focal length of the objective is 15 centimeter. So what is its magnifying power? L is equal to FO plus FE. This is 9, this is 15, this is FE. Then FE is equal to minus 6 centimeter. M is equal to minus FU by FE. If you are writing strictly, means minus also we had to consider, that I want to say. So this is minus of minus 15 by minus 6. So 3 2s, 3 5s will cancel. This will be 5 by 2 means 2.5. So M is equal to 2.5. Okay, this is the answer for it. Next, 61. Telescope has angular magnification of 10. Eyepiece is having focal length of 20 centimeter. L is equal to how much? M is equal to FO by FE. So 10 is equal to FO by 20. FO is equal to 200 centimeter. Then find the value of L. Therefore, L is equal to FO plus FE. This is 200. This will be 20. Totally, this value will be 220 centimeter, means 2.2 meter. Okay. See the next question. In an astronomical telescope in a normal adjustment, straight black line of length L is drawn in the on the objective lens. Here, this will be the objective lens. And that is objective. This will be eyepiece. Okay. A straight line is drawn here. A straight line is drawn, its length is capital L, they mentioned. Eyepiece forms the real image of this lens. The length of the image is L. Magnification of the telescope is how much they are asking. See, this line will serve as an object for this eyepiece. This is eyepiece, having focal length F. This is the objective having focal length F. This line will act as an object for the eyepiece. Then, what is the image distance you calculate? Object distance will be FO plus FE in normal adjustment. In normal adjustment, distance between the two lenses will be equal to FO plus FE. So, for eyepiece, 1 by f is equal to 1 by v minus 1 by u, basic formula. Here 1 by fe is equal to 1 by v minus 1 by minus FO plus FE. Okay. So 1 by V is equal to 1 by FE minus 1 by FO plus FE. FO plus FE minus FE by Fe into FO plus Fe. These two will cancel. Then V is equal to what will happen? Fe into FO plus Fe by FO. FO plus Fe is the length of the telescope. So this will be FO. That is the V value we got. Then magnification will be M is equal to V by U. Basic formula. This is equal to V by U. From this formula, how much we get? From this, V by L is equal to Fe by F naught. L is nothing but object distance. So V by U is equal to Fe by F. Okay. And another formula for M is size of image by size of object is equal to Fe by F. Size of image is small l, size of capital L is object is capital L. So from this FO by Fe is equal to capital L by small l. Since M is equal to FO by Fe, that implies M is equal to capital L by small l. Okay. So this is the answer for it. First option. Next, see the next question, what they are asking me. The magnification produced by an astronomical telescope for normal adjustment is 10. So M value will be equal to 10. Length of the telescope is 1.1 meter. Here not how when image is formed at the distance vision. You remove this. Okay. So M is, this is FO plus FE 1.1. Here this is FO by FE is equal to 10. That implies FO is equal to 10 FE. So here 10 Fe plus Fe is equal to 1.1. 11 Fe is equal to 1.1. Fe is equal to this value will be 0.1 meter or centimeter, meter. Therefore, FO value will be equal to 1 meter. Magnification formula will be how much? M is equal to FO by FE. 1 plus Fe by d. M is equal to FO value 1, Fe value will be 0.1. Here we got just now. And 1 plus 0.1 by, this will be 25 centimeter means 0.25. So if we calculate this one, finally M value, we will get it as 14. So here image is formed at the distance vision, distinct vision, like that you consider. Next, after 73, 79, you see a telescope has an objective lens of 10 centimeter in diameter and is situated at a distance of 1 kilometer from the two objects. Minimum distance between these two objects, which can be resolved by the telescope, when the mean wavelength is 5000 angstrom unit, is of the order of. So here, formula is x is equal to 1.22 lambda d by a. Okay. Then we have to find x value only. 1.22 lambda value 5000 angstrom unit means 5 into 10 power minus 7. And d value is 1 kilometer means 10 cube. A is the diameter of the lens. They gave this as 10. So if we calculate this one, finally this is 6.1 mm. So it is in the order of 5 mm. So in the order of 5 mm will be the answer for it. Next 80. These models are easy models. Try to concentrate on this. What they are asking: person cannot see distant object at a distance less than 1 meter. Calculate the power of the lens he should read. A book at a distance of 25 centimeters. So 1 by f is equal to 1 by v minus 1 by u. 1 by f means p. Here both will be negative, so it becomes minus 1 by v plus 1 by u. Here object is at 100 centimeter. We have to read that at 25 centimeter. So this value minus 1 plus 4 by 100. This is 3 by 100. Now actually, if we take these values in the centimeter, this will be in diopter. In meter, answer will be in diopter. So this will be 3 by 100 means actually in meters 3 by 1. This will be 3 diopter. Answer will be for this 3 diopter. Next, 84 you see what they are asking. A man is suffering from the myopia. A man is suffering from myopia can read a book placed at 10 centimeter distance. For reading the book at a distance of 10 centimeter with a relaxed eye, focal length of the lens required. So 1 by f is equal to 1 by v minus 1 by u. Book reading case, both will be negative. So minus 1 by v plus 1 by u. So here, image distance will be 10 centimeter, object will be at 60 centimeter. So minus 1 by 10 plus 1 by 60. So LCM, this will be 60. This will be minus 6 plus 1, minus 5 by 60. So F value will be minus 12 centimeter. Okay. Next, last problem. A student can distinctly see the object through a distance of 15 centimeter. He wants to see the blackboard at a distance of 3 meter. Focal length and power of the lens used respectively will be. So same 1 by F is equal to 1 by V minus 1 by U. Here both are negative. Minus 1 by V plus 1 by U. This is 15 centimeter. This will be 3 meters, na? 300. So 300 minus 20 plus 1 minus 19 by 300. F is equal to minus 300 by 19. So minus 15.8 centimeter. Power is equal to 100 by focal length. If F is in centimeter, 100 by 15.8. So if you calculate, minus 6.33 diameter. So this is the answer for it. Okay, with this we'll close the session now. Remaining will continue in the next class.